Hello, Luke. Welcome to Lesson 40. So today we're going to be really focusing in on negative exponents. And we're going to be applying those to quotients, so to fractions, and then we'll also be using them in the distributive property. All right, but the theme for today is going to be negative exponents. So as just a quick review, let's recall what an exponent is and kind of work from there. So if I have, something like x to the third, what does that mean? Well, we should know this by now. That just simply means that we have an x being multiplied by itself 3 times, right? And we've also talked about what happens when we have a negative exponent. So if I have a negative exponent, such as x to the negative 2, we can rewrite this as 1 over x to the positive 2, right? If we move this negative exponent term down into the denominator, it becomes positive. Similarly, if I have 1 over x to the negative 2, I can make that negative 2 positive by moving this negative exponented term up into the numerator. So if I move this up, we get x to the positive 2 over 1, which of course can be simplified to just x squared, right? So moving this term with the exponent from one side of this fraction sign, or fraction bar, to the other side will simply change the exponent. And that applies even if the exponent is 1. So if I have 1 over x, I can move this x into the numerator by changing the sign of the exponent. So this is x to the 1. It's just not visible. If I move it into the numerator, it becomes x to the negative 1. Okay? And then if I have, x to the negative 1, and I want to move that down so that we have a positive exponent, we would move it into the denominator, because this is essentially x to the negative 1 over 1. So if we move it into the denominator, we have 1 over x. All right, so that's all basic review. There's one other thing, too, that we should talk about, and that is we've gone over this before, but if we have exponents with more than one similar term, such as x squared times x to the fourth, and we're multiplying these, we recall that to do that, we add the exponents. So x squared times x to the fourth becomes x to the sixth, right? Now, similar to this, and really the same concept applies when we have negative exponents. So if I have x to the fourth, and I multiply that by x to the negative 2, I'm just going to add the exponents, correct? And in this case, I have a negative 2, so I'm taking a 4 plus a negative 2, which is just going to give me a 2, right? So we have a negative exponent, but it doesn't change anything. The concept still applies. We simply add the exponents when we're multiplying. Remember, that's so important to remember that we're only talking when we're multiplying. If this were an addition sign, it would be a completely different story. We wouldn't be able to do anything with it because they're not like terms. They just have the same variable. Okay? So only in multiplying will we add the exponents. All right? Now, today, then, we're going to kind of extend this to division problems, quotients. All right, whenever we see quotient, we should be thinking division, right? Because remember, a quotient is just the solution to a division problem. So let's take a division problem. What happens if we have, x to the 7th over x squared? Now, we've already been simplifying some of these, and in general, I've been just kind of reminding you that x to the 7th would indicate x times itself, 7 times. Let's see, 3, 6, 7 times over x squared, which would be x times itself twice. And we would say, oh, well, this x can cross this x can cancel this x, and we're just left with 5 x's, right? So we end up with x to the 5th. And that's kind of the general thought that we've been using when we come across these kinds of expressions, and we're trying to simplify them. Another way to think of this, though, and perhaps an easier way to think of this, is to recall that the rule in regard to negative exponents, and that when you move a term up from the denominator, it changes the exponent sign. Okay, so if we're looking at this, we could think of it as x to the 7th. Well, let's move this x squared up into the numerator. Okay, and if I want to move that up into the numerator, the sign is going to change, and we're going to end up with x to the 7th times, and I'll just do this maybe in a different color, x to the negative 2, right? I took this guy and I moved him up, turning it into a negative 2. And now, once I have it in this form, it's perhaps easy for me to see that all I have to do is add the exponents because we are multiplying. So 7 minus 2 is 5, and I get x to the 5th, all right, which is the same answer that we got up here. So we end up with the same answer. It's just perhaps a simpler way to look at things, remembering that you can move this up, changes the sign of the exponent, and then we add the exponents. So you could basically do some of these in your head. So if I have x to the 5th over x to the 3rd, and I want you to simplify that, you can just recognize that this x to the 3rd could be moved up. That would become x to the negative 3, and then my solution is going to be x to the 5th minus 3, right? I'm going to subtract those exponents, and x to the 5th minus 3 is going to be x squared, right? So we can do a lot of it in our heads. Okay, that is the general principle behind the quotient rule for exponents. I know it's a very fancy name for it, but it's actually a very simple concept, and it's one that we've really already learned. We're just kind of bringing it front and center now and making sure that we understand that we can do these things. So let's try a couple of problems and see how we do. So let's take this first problem. Go ahead and try to simplify it on your own using negative exponents, or using the idea, the concept of moving the exponents up into the numerator. All right, so let's see how you did. This one's pretty straightforward. It's very similar to the ones that we've already done. So if I have x to the 5th over x to the 3rd, I can rewrite that as x to the 5th times x to the negative 3, which is going to give me x squared. And there we have it. All right, let's go to the next one. And you know what? Actually, just pause the video, and just to save you some grief and you're not constantly pausing the video and restarting it, why don't you go ahead and do the next 3. Pause the video, do the next 3, and then we'll do all 3 of them together. All right, so let's see how you did. We have x to the 8th over x to the negative 5. And again, we'll move that denominator up into the numerator, and that's going to change the sign. So we have x to the 8th times x to the 5th now, the positive 5th. We can add the exponents, and we end up with x to the 13th. All right, this next one, we don't have numbers, we have variables, but we're going to treat them just like numbers. So if I have x to the a over x to the b, I could rewrite this as x to the a minus b. All right, hopefully you see that. All I did was I kept the numerator, and then I moved the denominator up into the numerator, which of course is going to change its sign, in this case, to a negative b. And then when I'm multiplying like variables, I just simply add the exponents. So it's going to be x to the a plus a negative b, which is the same as x minus, or to the a minus b. That's how I got this. All right. Very good. Let's go on to the next one. So here we have x to the a over x to the negative b, very similar to this one. And again, we're going to keep the numerator the same, x to the a. We're going to bring the denominator up. It's going to change its sign to a positive b. So I'm going to have an x to the a times x to the positive b, which is simply going to be x to the a plus b. Okay? All right, so if you didn't get those, just ponder upon that and make sure you understand how I came up with these solutions. All right, let's go on to some others here, making them just a little bit more complicated, maybe a little messier here. Let's take this one. And there are actually many different solutions to this. If the directions were to say, simplify this problem, okay? Well, there are multiple ways that you could simplify this. You could try to do what we've been doing before and move everything from the denominator into the numerator. You could do the opposite of that. You could take all of the items in the numerator and bring them into the denominator. That would be fine too. Or you could do a mix of both and just try to eliminate negative exponents, for example. You could write it with all positive exponents, or you could write them with all negative exponents. So there's many different ways to simplify this. So if they were to just say simplify, you really have your choice on what you would like to do. Most of the time, they're probably going to indicate what they want you to end up with in your final answer. So they might say simplify and write all of the exponents in the numerator. Or they might say simplify and write with only positive exponents, or simplify and write with only negative exponents. Okay, so they'll probably give you some directions on which way they want you to go when simplifying this. But just to kind of show you that this can be done in multiple different ways, let's do it at a couple different times here and show that. So if I have this expression, let's say first off, let's move everything from the denominator into the numerator. All right, let's do that as our first way to simplify this. So we're going to keep the numerator as it is. So we have x to the negative 3, y to the second, z to the negative 2, w to the fifth. So that just stays the same. But now we're going to move this denominator up into the numerator. And what happens? Well, the exponents are going to change their signs. So we're going to have x to the negative 2 now, y to the positive 4, to the positive 4, z to the positive 4, and w to the negative 3. Okay, we've just changed all the signs. Now, once we've done that, we can now look through this and look for like variables to combine. It's all multiplication. So we can combine like variables by adding the exponents. So if I've got an x to the negative 3, do I have any other x's in here? I sure do. There's another x right there. So x to the negative 3 times x to the negative 2. If I add the exponents, I'm going to end up with x to the negative 5, right? So that one's taken care of. Then we have y squared. Do we have any other y's? Yes, we do. We have one right here. So y squared times y to the 4th, well, that's going to give us y to the 6th. And again, we're done with that one. I'll just cross it out so we don't get confused on where we've been already. Then we have z to the negative 2, and we have z to the 4th. Well, let's combine those. Negative 2 plus 4 is going to be a 2. So the z's are done. We can get rid of those. And then w to the 5th and w to the negative 3. So if we combine those two, we end up with w squared. And then we've used up all of our terms. So our solution, our simplification, is going to be this guy right here. Okay? Now, let's just do this problem again, only in a different way. So maybe I'll see if I can't cut and paste this here. There we go. Do that, and then maybe move down here. There. Okay, so there's our exact same problem here. Now, let's just try it in a different way. Now, let's try to do it by, we'll write all of the... we'll write all of the exponents as positive. Okay, so in this sense, we would really very similarly actually do what we did in the first problem. We could actually use that as our first step to move everything up into the numerator, get this solution, and then take one step further and write it with positive exponents. The only negative exponent we have is this negative x to the negative 5. So we would want to move him down into the denominator to make him a positive exponent. And that would give us the solution y to the 6 z squared w squared over x to the 5th. That would be a very plausible and correct solution for this problem. Okay. So that would be another solution. What else could we do? Well, we could write it with everything in the denominator. Okay, so let's take the same problem here again, the same solution. We'll just take that one step further again and say, all right, if the directions told us they wanted everything in the denominator, well, then all of this has to be shifted down into the denominator. And so to do that, well, in the numerator, we're just going to have a 1. Right? Because we're moving everything down into the denominator, which would just leave us with a 1 in the numerator. So we'd then have x to the negative 5. That would become x to the 5th. Y to the 6th would become y to the negative 6th. Z to the 2nd becomes z to the negative 2. And w to the 2nd becomes w to the negative 2. All right? And that would be another acceptable solution for this simplification problem. All right, so you can see there are multiple different ways to do it. This first step that we took is kind of the stepping stone to many of these other ways as well. All right, just kind of moving everything up into the numerator first and simplifying is a good place to start. Another way to do it, and maybe I'll do that over here, just to show you that there are so many different ways you could attack this problem. If I start with the original problem here again, one other thing that you could do is you could say, okay, well, looking at this problem, let's try to simplify by combining like variables first. So you might say, okay, I have an x here. I don't have any other x's up here, and actually this numerator is completely simplified. There's nothing I can do in the numerator. In the denominator, again, it's completely simplified. There's nothing I can do in the denominator. So now I could just look for things to kind of start crossing things out. So I could say, okay, I have x to the negative 3 right here. Do I have any x's in the denominator? Well, I sure do. This guy right here, right? So let's just move him up into the numerator. Well, that would give me x to the negative 3 and an x to a negative 2 because the sign changes, and that's going to give me x to the negative 5. Okay, and then you might say, well, okay, y squared, what else do I have? Well, I have a y to the 4th down here, and I can move that y to the negative 4th up, becoming a positive 4. The 4 would then add to the 2, and you get y to the 6. Okay, and then I have z to the negative 2. I could say, again, this z to the negative 4 can move up, becoming a positive 4. And then z to the negative 2 and a positive 4 is going to be z to the 2nd. And then same thing with the w. The w can move up, and that would give me w to the 2nd. So essentially, you can do a lot of this in your head as well. Here I wrote it all out, and we kind of went through it. But if you can recognize these things, you can start to kind of do it mentally in your head and come up with these answers without writing out all of this elaborate work. All right. I wouldn't probably recommend that for the first couple of lessons here, just so that you can kind of get into the habit of doing it the long way, and then you'll be doing it that way only in your head later on. So, all right. So that's kind of how that's working. Now let's move on here and get a little more specific. Let's actually go to we'll go to this. So here we're actually taking what we've learned here with negative exponents and applying it to an expansion problem. So we're going to be using the distributive property here to expand this. And in so doing, we'll be applying our negative exponent quotient rule. All right, so this is all review, really. We're just expanding this problem. So we're multiplying our outside term by the first term, and then we're multiplying it again by the second term to expand it out. So let's go ahead and do that. This first term, we're going to multiply the numerators. So we have 4x times x to the 3rd, right? And then in the denominator, we've got y to the 3rd times y to the 2nd. In the denominator. That's the first multiplication here, the first term being multiplied by the outside term. Then we'll multiply it by the next term. This is a positive, and we're multiplying it by a negative term. So this is going to be a negative. Oops, not an equals, a negative. And if we multiply the numerators, we end up with 4x times 4x to the negative 2y to the third all over. The denominators are going to be y to the third times x squared y. Okay? So now we can go ahead and simplify this out. We have 4x times x to the third. Well, that's going to give me, and I'll put equals here, 4x to the fourth, right? We add the exponents. In the denominator, we end up with y to the fifth in the denominator. And then over here we have 4x. Well, let's multiply our coefficients. 4 times 4 is 16. And we have an x times an x to the negative 2. Well, that's going to be x to the negative 1. And then we have just a y to the 3 all by itself. In the denominator, we have a y to the third times a y to the 1. Well, that's going to give me y to the fourth, and then we have an x squared left over. So now we've just kind of simplified. Now we can take this one step further and kind of use what we've learned in the previous part of this lesson. Let's take it and move everything up into the numerator. All right? So if we move it up into the numerator, we have 4x to the fourth times y to the negative fifth, okay? And then we have minus, and then we still have that coefficient 16. We have all of this numerator, x to the negative 1, y to the third. And then we move this guy up. We have now y to the negative 4, right? This y to the fourth gets moved up. X squared gets moved up, becomes x to the negative 2. And now we can try to actually simplify this a little bit more. So this first term, there's nothing we can do. There's no simplification that can be done there. We're dealing with x's and y's and the coefficient of 4, nothing that can be done. Then we have our minus 16. Here we have an x to the negative 1, and here we have an x to the negative 2. So we can combine those and get x to the negative 3. And then y to the third and y to the negative fourth, we can multiply those out and get y to the negative 1. And there we go. We're as simplified as we may want to be. Now we could take this one step further and say, well, maybe I want to not have negative exponents. Well, we could certainly rewrite this without negative exponents by moving the negative ones down into the denominator. So the y to the negative fifth becomes y to the fifth in the denominator, minus 16. Well, that's just 16 by itself in the numerator, and we end up with x to the third and y in the denominator. That would be another way to write the solution to this problem. Either one is acceptable. All right? Okay, so let's move on. Why don't you pause the video, try this one, and then we'll do it together. Now notice, though, that here they're actually specifying what they want the final answer format to be in. They want the answer with all variables in the numerator. So they want all variables in the numerator. So make sure that your final answer does reflect this. All right, so let's go ahead and try this one together. So distributive property, we've done this a million times now. We'll multiply it by the first expression. We end up with x to the negative 2y times y to the fourth over x squared. And then this is going to be a minus. And then we have x to the negative 2 times x to the fourth over, a y as well. Forgot about this y here. Y squared over y squared. All right. Now we can simplify and move things up. They want things in the numerator, so let's just do that. Let's put the numerator or the denominators into the numerator. So we have x to the negative 2. Now I'm going to combine these maybe. Y times y to the fourth. We know that that's going to be y to the fifth. And then we'll move the denominator up into the numerator. That's going to give us x to the negative 2. And we have our minus. And now we have an x to the negative 2 and an x to the fourth. We're multiplying those, add the exponents, x to the squared, or x squared is what we'll get, times the y. And then we move this y squared up into the numerator, so we're going to multiply that by a y to the negative 2. And now we have everything in the numerator. So final step is to go through and simplify anything that still needs to be simplified. And we notice now that we still have x's here, so we can multiply those. X to the negative 2 times x to the negative 2 is going to give me x to the negative 4. And of course we have the y still. Over here, I have an x squared. There's nothing I can multiply that by. And then I have a y times a y to the negative 2. That's going to give me y to the negative 1. And now I've got everything simplified. Everything is in the numerator. So we're in the correct format for what the directions specified. Okay? So hopefully that makes sense. Let's try another one. So give this one a shot. Here, though, they want all variables in the denominator. So keep that in mind. The final format for the problem solution should be with all the variables in the denominator. Okay, so give that one a try. All right, so let's give this one a whirl. Same process here. We'll multiply this by the first term. So we have k squared b in the numerator times a b to the negative 1 all over p to the negative 2 times k squared. And then we have a minus k squared b times, and we'll put the coefficient first here. So we have 4, and maybe we'll just write it as 4p squared times k squared b. And then we have a p to the negative 2 times the b. Okay. All right, now let's start moving things into the denominator and or simplifying. And maybe we'll simplify first and then move things into the denominator. It doesn't matter really which way you want to do it. So looking at the first term, I might recognize that, okay, I've got some b's up here. Let's simplify those, make it a little bit easier for me. So this is going to equal k squared. Now I've got a b times a b to the negative 1. Well, this is b to the 1. If I add the exponents, I get b to the 0, right? And remember, what is b to the 0? Well, that's always going to be 1. So it's really just k squared times 1, which is just k squared. So in a sense, the b's eliminate each other. And I'm left with just k times a in the numerator. The denominator, there's nothing I can simplify there, so I'll leave it as is. And then we come over here, and I guess there really isn't anything that we can do over here either. So we've got, 4, maybe if I write them in alphabetical order, I've got 4b k squared p squared over b p to the negative 2. And now I can look at the format that they want. They want the format with all variables in the denominator. So that means that from here, we have to move everything into the denominator. So in the numerator, we're going to have just a 1 because everything is moving into the denominator. So we've got this k squared gets pushed down, so that becomes k to the negative 2. And then this a gets moved down, that becomes a to the negative 1. And then, of course, I have everything else that's already in the denominator. And then I'm subtracting from that. Again, it's going to have to be a 1 in the numerator. And this is kind of interesting. So we have a 4. What do we do with the 4? Well, I should have said that. So up here they said all variables in the denominator. 4 is not a variable. 4 is a coefficient, right? So the 4, we're going to actually leave that in the numerator. So in this case, it won't be a 1, it'll be a 4 that we'll leave in the numerator because that's what we have over here. He's not a variable. So we leave him there, but everything else is going to go down to the denominator. So we move the b down, he becomes b to the negative 1. K down becomes k to the negative 2, and then p is going to become p to the negative 2. And then in the bottom already, in the denominator, we can't forget what's already there. We have a b and a p to the negative 2. All right, the denominators are getting a little crowded here. Let's move this over, give us a little more real estate here to work with. Let's try to simplify this now. So, is there anything that can be done? Well, in this first term, we have a k to the negative 2 and a k to the second. So 2 plus a negative 2 is 0, k to the 0 is a 1. So in a sense, these just eliminate each other. And then there's nothing else that we can multiply out. So we end up with a to the negative 1, p to the negative 2. And then over here, we still have our 4 in the numerator. And that's going to be over, let's see, we have a b to the negative 1. We have a b to the positive 1. So again, those are going to eliminate each other. And then we've got a k all by itself. There aren't any more, so we'll just do k to the negative 2. And then we've got p to the negative 2 times p to the negative 2. Well, that's going to give me p to the negative 4. All right, so now we have it written with all of our variables in the denominator, and it's as simplified as we can get it. There's nothing else that we can do here. So this is going to be our solution. All right. Excellent. All right, let's, yeah, you know what? I think we're just going to call that a day. So just as a recap, we didn't really learn anything too new today. We just were looking at how to work with negative exponents and how we can use that to help us simplify problems a little bit more easily. And we looked at different ways in which a solution can be expressed. We can express it with everything in the numerator. We can express it with everything in the denominator. We could express it with only positive exponents. We could also express it with only negative exponents if we wanted to. So there's multiple ways to express the solution, but all of those solutions are equivalent. All right, they look different, but they all represent the same value. So I might even go back here where we were looking at all the different ways that we could write the solution to this problem. All of these different ways are equivalent. So if I knew what x was, and if I knew what y was, and z and w were, I could plug the numbers in, and I would get the same value for this expression as I would for this expression, as I would for this expression. They are all equal. They're just a different way to view it. Okay? Very good. So we will stop here for today, and we will continue tomorrow.